Problem, I need to find the center, foci, and vertices of the ellipse x squared plus 2x plus 9y squared minus 54y plus 1 equals 0. In order to do this, I need to put my ellipse in standard form. Standard form for an ellipse is either x minus h, quantity squared, over a squared plus y minus k, quantity squared, over b squared equals 1, or we can switch the denominators of those two fractions and put the x over b and the y over a. Now, what you want to keep in mind is that a is always going to be larger than b. That's why it could wind up in one of those two formats. So, in order to do this, I need to use the technique of completing the square. I'll start by rewriting, putting my x terms together, and then leaving a space. And then I'll put my y terms together, and again leave a space. And then I'll take my constant term, move that over to the right side of the equation. So I have x squared plus 2x plus blank, fill that in a minute, plus 9y squared minus 54y plus, and then another blank, equals negative 1. So x squared plus 2x, we have to complete the square here. We're all ready to do this because the coefficient of x squared is 1. So for completing the square, I'm going to take half of the coefficient of the x term, so in this case that's a 2, half of 2 is 1, and square that, and I still have 1. So I'm adding 1. Oops, here we go. So I'm adding 1 to this expression. And if I add 1 to the left-hand side, I have to add 1 to the right-hand side. Now with the y, it's a little bit more complicated because the coefficient of y squared is not 1 right now. So I'm going to rewrite this again, and as long as I'm rewriting, I'm going to go ahead and write x squared plus 2x plus 1 in factored form. So that would be x plus 1 quantity squared plus. Now I'm going to factor the 9. The nice thing is that 9 divides into 54 evenly, but even if it didn't, I would still factor out a 9. So I'm not looking for a common factor. I need to factor out whatever the coefficient of y squared is. And I have y squared minus 6y plus, and I still have a blank here, equals, and, well, let's just go ahead and make that 0. Okay, so now I can complete the square. So y squared minus 6y, half of 6 is 3, square that is 9, so I'm adding 9, but I'm not really adding 9 to the left-hand side. I'm adding 9 within parentheses. But what you need to notice is that we're actually adding 81 because we're adding 9 times 9. And you could redistribute the 9 on the outside here and see how that turns out, but I think you can just imagine it and then realize what it is you have to add to the other side. All right, so now I have x plus 1 quantity squared plus 9, and this in factored form is going to be y minus 3 quantity squared, and that equals 81. Now, we're still not in standard form, because in standard form, the right side of the equation has to be a 1. So I'll divide both sides of the equation by 81. And that'll give me 1 on the right-hand side. So I have x plus 1 quantity squared over 81 plus, and I'll simplify so that I have y minus 3 squared over 9. And 9 over 81 gives you 9. So in the denominator. So now I'm in standard form, and I can see that the denominator of the x part of the equation is larger than the denominator of the y part of the equation. So we have this type, where a squared is under x. So now I'm going to figure out what a squared and b squared are, or a and b are. So just by looking at this, I can see that a is 9 and b is 3. But there's also another value that we need to find, which is c. And so we find that by saying that b squared equals a squared minus c squared. So b squared was 9, a squared was 81, and now I can solve for c squared. So I'll just manipulate my terms. C squared equals 72, and so then c is the square root of 72, and it's really plus or minus, but we're going to take care of that plus or minus later on, so I'm not terribly concerned about it for the moment. And let's see, that simplifies to 6 times the square root of 2. All right. So now we have a, b, and c, and we're ready to find our center, foci, and vertices of the ellipse. Now what I can tell about this ellipse is that the major axis is parallel to the x-axis. So the major axis is always going to be parallel to the axis of the variable that's over the larger denominator. Oops. There you go. All right, and let's see, what else do we know? We know that the center is at h comma k, and that's consistent with all three conic sections that you're looking at, the parabola, the ellipse, and the hyperbola. So our center for this ellipse is -1 comma 3, and I got that from h is the opposite of this number, so it's x minus h format, so a +1 is going to give you an h value of -1, and then we have -3 here, so the k value is +3. So there's my center. I always start with the center because then the foci and the vertices are going to follow from there. So the foci, how I find the foci, I like to sketch the graph very roughly. So I've got my center here at -1 comma 3, and I know that my major axis is parallel to the x-axis, which means that my foci and vertices are all going to lie on this horizontal line y equals 3. So what are they? Well, the foci, what I'll do to find those is I'll take the x value, -1, of the center, and I will add the value of c to get one focus using the same y value of the coordinate, and then I'll subtract to get the other one. So I can just write this a little shorthand, -1 plus or minus 6 square root of 2, comma 3. So we've got 2 foci. I want to approximate, well, what is the value, roughly, of 6 times the square root of 2? And that's roughly 8.5. We don't need to be super precise. So I know that my one focus is going to be, I'm going to count from the center, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that was way too far. So I'm just going up to 8.5 from there, right? So here's 8.5, we'll say. And then we want to go 8.5 in the opposite direction. And then our vertices. We're going to do roughly the same thing. I'm going to start with my center, but now I'm adding and subtracting the value of A. So since A is 9, now here I actually have a whole number, so I'm going to write these as 2 separate points. I don't want to leave it like this. So -1 plus 9 gives me 8, and we have 8 comma 3, and then -1 minus 9 gives me a -10, so then I have -10 comma 3. So I have my foci and my vertices. My vertices will be a little bit further out from the foci, of course, and that's how we find those values. So they didn't ask us to sketch the graph, but we could. I would just go up 3 units because B is 3. So I go up 3 units, down 3 units. That gives me the height of my ellipse from that center. And, all right, not the greatest ellipse in the world, so should be a little bit more accurate, but for our purposes here in this video, I'm going to go with that. And so that's how I get that answer.